Alright guys, I'm back again. On this problem that we're going to be looking at, we need to go over Avogadro's principle. This is out of section 10.4, unit 4, chapter 10 of course. And here they just mentioned that when measured at the same temperature and pressure, equal volume of gas contain equal number of moles. So the gas volume is directly proportional to the amount of gas. And that's what this symbol means, directly proportional to. Anyway, at a fixed pressure and a fixed temperature. And what does this mean for us? Well, let's think about stoichiometry. But before we get into that, we do need to go over some definitions. STP stands for standard temperature and pressure, which temperature would be 273 degrees Kelvin and pressure would be 1 atmosphere. Now, standard molar volume in this is basically this. The volume that 1 mole of a gas occupies at STP is the volume of 22.414 liters. Now let's look at a problem involving stoichiometry at STP. It says that a gas volume can be used in solving stoichiometry problems, provided that they are measured at the same temperature and pressure. Well, here's our first problem. They ask us how many liters of hydrogen are measured at STP are needed to combine exactly 1.5 liters of nitrogen, also at STP, to form ammonia. Well, the first thing you would want to do is you would want to write down the balanced equation. So for us, that's N2 plus 3H2 yields 2NH3. Now luckily for us, they were nice enough to balance this. Now they tell us that they want us to find, what was it again? I don't remember, I'll have to look. It says how many liters of hydrogen. So they ask us about how many liters of hydrogen. What I would do is under this I would put a number sign and liters. So that would be number of liters of hydrogen. That's what that tells me. And they're going to tell me that they're going to give me 1.5 liters of nitrogen. So underneath the nitrogen I'm going to write 1.5 liters of nitrogen. Okay, so I guess you can see how I've got this set up from this. Now, basically this is all that we have to do. Okay, this is going to seem kind of silly in some aspects, but hopefully we'll make a connection here. We were given 1.5 liters of N2. Now let's stop and think for a second. What do we know about liters? Well, they told us this. They told us that there are basically 22.414 liters in what? Well, 1 mole. And in this case, it's 1 mole of N2. Now we need this step technically so we can use stoichiometry, basically the coefficients in the balanced equation, the 1, the 3, and the 2. But here, notice that we only have 1 N2. So here I'm going to write 1 mole of N2. Now here, notice that I have 3 moles of H2. That's the hydrogen gas, by the way. And the next thing I'm going to do is I want to go a step further. Now this is the part that seems redundant. Okay, down here I'm going to write 1 mole of H2. And if you notice, up here I'm going to have basically, once again, the 22.414 liters. Okay, now if you notice, the 22.414 would cancel out, and we're going to be left with basically, almost really no units, because you have liters of N2 canceling out with liters of N2, moles of N2 canceling with moles of N2, mole of H2, mole of H2. And the only thing left is the liters. Okay, I'm going to show you an easier way to write this out, but for the time being, let's go ahead and work this out. Okay, let's turn the calculator on. Let's punch this in. We have 1.5. Whoops, let me clear that. We have 1.5 times 3. Whoops, I forgot the time sign, didn't I? I'm sorry. Times 3. Now, the 22.414 cancels with this one, so I don't have to worry about it. is 4.5. Now on the bottom, after we cancel out the 22.414 with this one, it's gone, and I'm only dividing by 1. So my answer is 4.5. Now, you and I both know that this is 4.5 liters of H2. Now let me show you the way that most chemistry professors and teachers explain this. Let me move the calculator out of the way really quickly. Usually they just say, well, as long as you know it's an STP, standard temperature pressure, then basically this is the way that you can set it up. You can just say 1.5 liters of N2 over 1, and then you can almost just skip this step and just look at the molar ratio. For 1 mole of N2, there's 3 moles of H2. And basically from here, if you notice, you have what you need. But what they do is they pretend, instead of to use moles, they pretend that these are really just liters. You know, I'm so used to old school teaching that this is the way that I was taught many moons ago, and I still work it that way. But I do try to show my students now that, you know, basically you can just treat the moles as liters. So basically you're just saying 1.5 liters of N2 over 1, and then there's instead of 1 mole, there's 1 liter of N2, and here there's 3 liters of H2. That way you can have liters of N2 cancel with liters of N2, and you're left with liters of H2, and that's how you get the 4.5 liters of H2. I mean, it's essentially the same thing, but to me this has always been sloppy, and I just don't like this way. This is the way that I prefer it. You know, that way I can see that the students make the connection of a mole is this many liters. So that's me though. So it's really up to your professor or teacher. Anyway, just watch the video a few times, and here's the question again. And once again, here is the work. I hope it helps, and really the only thing left is the credits. So I hope this helped you, and let me know if it did. Alright guys.